I'm Ms. Fung. Let's have a look at rectangular hyperbola. Let's plot the graph first so we can see what the shape looks like. The equation for rectangular hyperbola is y equals 1 over x, where x is not allowed to be 0 because 1 over 0 is undefined. So let's see what 1 over x looks like when we plot various numbers in there. So when x is -3, we would have 1 over -3, which is -1/3. Let's plot this. So x is -3, y is -1/3, right there. When x is -2, we have 1 over -2, which is -half. When x is -1, we have y equals 1 over -1, which is just -1. When x is a fraction, however, so when x is -1/2, 1 over -1/2 is like saying 1 divided by -1/2. Or you can do 1 times the inverse of that, so 1 times -2, which is -2. So we're getting lower and lower in values. What happens when we have positive values? 1 over 1/2 is equal to 2. 1 over 1 is 1. 1 over 2 is 1/2. And we can see that 1 over 3 is getting smaller. And the bigger the x value, 1 over 10 for example, what do you think it will look like? It will get smaller and smaller and smaller, but it will never touch the x-axis. And likewise, when we get fractions, like 1/2, it will become 2. When we have, let's say, 1 over 10, so 1 over 1 over 10, it will become 10. So it gets bigger and bigger, but it will never reach infinity. So with this graph, we can see that it approaches the x-axis and approaches the y-axis. This rectangular hyperbola has asymptotes. So asymptotes are the lines that the graph will get really close to but never touch. So let's have a look. The horizontal asymptote is this line going across. We can see that as x reaches infinity, so as our x value got bigger and bigger, so 10, 20, 30, we get 1 over 30. It's getting really close to, the y value gets really close to 0 from the positive side, but it never gets to 0. And likewise, when x approaches negative infinity, like -10, -20, -1,000, -a bajillion, then 1 over that, it's almost 0, but not quite. And it's approaching 0 from the negative side of the y-axis. We can look at the vertical asymptote. As x approaches 0 from the positive side, so if it's closer to here, we can see that the y values are getting really big. So when x is 1 over 10, our y value will be 10. When x is 1 over 100, our y value will be 100. So it's getting huge. So it's getting closer and closer to infinity. And when x is approaching 0 from the negative side, so getting close to 0 from this side, then we can see that the y values is getting bigger and bigger and bigger, but to negative infinity. So our horizontal asymptote, so this line here that the graph never touches, is at y equals 0. And our vertical asymptote, the line which our graph never touches, is at x equals 0. Be very careful you don't mix these up. Let's talk about transformations. Let's have a look at the dilation. So here we have a graph that's been dilated. You can see that it's moving further away from the origin, this red graph, and this graph over here, the purple graph, is getting closer to the origin. Now the red graph moving further away from the origin might have a dilation factor of 2. And we describe that as the dilation factor of 2 from the x-axis. Whereas the purple graph, as we get closer to the origin, it can have a dilation factor of 1/2, and it'll look like that. And we describe it as a dilation factor of 1/2 from the x-axis. Once after dilation, let's talk about reflection. So here is our original graph. If we reflect along the x-axis, so if the x-axis was a mirror, it will flip, and that section of the graph in the first quadrant will end up in the fourth quadrant over here. And this section of the graph here in the third quadrant would end up in the second quadrant over there. It doesn't matter if we're reflecting on the x-axis or the y-axis for this graph, we get the same result. If we flip along the y-axis, the part of the graph in the first quadrant would end up over here in the second quadrant, and the part of the graph in the third quadrant would end up over there in the fourth quadrant. So the reflector graph looks like this, and we describe it as reflecting in the x-axis, although it's the same as reflecting in the y-axis. Let's have a look at this equation. Here we have the graph, and it looks like it has been moved to the right by 2 and up by 3. So it has translated up by 3, so our asymptote also has moved, so it's y equals 3, no longer y equals 2, and it has moved to the right by 2, so our vertical asymptote is now x equals 2. We also notice something about this graph. It has an x-intercept and a y-intercept, and again, to figure what they are, you do the usual technique of substituting the other variable as 0. So if you want to look for the y-intercept, substitute x equals to 0, and vice versa. So here's our standard equation for rectangular hyperbola. H is their horizontal translation, k the vertical, and a is our dilation. Let's do an example. Sketch this. So here we can see that there's a dilation factor of 4 from the x-axis, and it has been moved to the right by 1, or translated to the right by 1, and translated down by 2. So translating to the right by 1 means our asymptote is now x equals 1. If you forget whether it's x or y equals 1, so just remember, you're moving this way, that line doesn't change, but that line changes, and those lines are x equals value. So the vertical translation gives us a asymptote of y equals -2, because we've been moving down by -2. And now we can find the y-intercept, because there'll be 1 there, by substituting x equals 0. So 4 over -1 is -4. -4 minus 2 is -6. So 0, -6 is our y-intercept. Do we have an x-intercept? Yes, we will over there. So when y equals 0, we have 4 over x minus 1 equals -2. Bring the -2 to this side, it's +2. Bring the x and minus 1 over, and then we have 4 on that side. So 4 divided by 2 is 2, and then plus that 1 over there is 3. So let's plot those two intercepts in and then sketch our graph. On paper, however, I would sketch the graph first and put the dot in after, because it's a lot easier than trying to go through the dot. Don't forget that. Example 2. Here we have a dilation factor of 2. Remember that we do not use the negative sign in our description of dilation. The negative sign is a transformation of its own. It is reflecting in the x-axis. And then we look at the 1. That 1 describes a translation to the left by 1, which means our vertical, not horizontal, vertical asymptote has moved this way by 1, or in other words, the asymptote is now x equals -1. So let's sketch that. X equals -1. It has not moved up and down, so our horizontal asymptote is still at y equals 0. Now it's a negative graph, so instead of drawing in the first and third quadrant, we're going to draw it over here, the second quadrant and the last quadrant. So if we draw it over there, we notice that there's going to be a y-intercept that's going to be negative. So let's find it. So to find the y-intercept, we let x equal 0, and we expect our answer to be negative because it's going to be down here. So -2 over 1 is just -2, and it's negative like we expected it. So let's sketch the graph. Now that's it for me today. Please revise, have a look at the video again if you need to, and I'll see you next time. Bye!